This video covers topic 19.3 over simplifying radical expressions. The bell work for these notes asks us to identify the pattern when taking the square root of terms, and then after that, simplify the square root below. So I'll write the pattern over here. The pattern deals with our exponents. If we have an even exponent, we just divide by 2 and bring everything outside the square root. However, if we have an odd exponent, we still divide by 2. We will get a number 0.5, and the 0.5 will be there every time. The number goes outside, and then we leave one letter inside the square root. So when I look at this example, my even exponents are a to the 4 and c to the 6, so we'll do those first. 4 divided by 2 is 2, and that will go completely outside of the square root because it's even, so there's nothing left under the square root. For the c's, 6 divided by 2 is 3, and that will also go completely outside of the square root. So with the even numbers, you have nothing left under the square root. Remember, we're looking for groups of 2 or pairs, so even numbers can pair up evenly and have nothing left inside the square root. Now the odd numbers, we still divide by 2. And when you get a 0.5, that tells you you leave something under the square root. You will always only leave 1. And then the number outside, the b to the 2.5, the 2 is going to go outside the square root. D is odd. So we take 7 divided by 2 and get 3.5. The 3 goes outside. 0.5 tells me I leave 1 inside. So that is reviewing our rules for simplifying square roots with letters. So problem 1 has already been done for us. They broke 684 up into 4 and 162. 4 can be broken up into 2 and 2, and you cannot break the 2's up any further. 162, they broke up into 6 and 27. And remember, the order in which you break these up does not matter as long as you break them up correctly. 6 breaks up into 2 and 3, 27 into 3 and 9. 3 cannot go any further, but 9 can go into 3 and 3. So we have 2, 2, 2, 3, 3, 3, 3. So that is all written out here. Whatever pairs you take out, we take out a set of 3, another set of 3, and a pair of 2's, and those all come outside. So we took out a 2, a 3, and a 3, and those multiply together to get 18. And then left on the inside, this 2 over here does not have a friend. No one will go outside to play with it, and so that 2 stays inside the square root. So let's try problem 2 together. 512 needs to be broken up. I can see that 512 is even, so I can always start by 2. So 512 divided by 2 is 256. Now, something I forgot to do, it's always important to try the square roots first. Okay, that didn't work, so I'm good. Now let me try the square root of 256 because that kind of sounds familiar. Oh, 16 and 16. Now remember, when you find a pair, even if it's not broken down all the way, when you find a pair, you can stop, or you can keep going. You're just going to build it back up. So for this, my pair of 16s is going to go outside, and then the 2 is going to stay inside because it has nobody to play with it. For the square root of a squared, we take 2, my exponent, divided by 2. 2 divided by 2 is 1, and because it's even, I have nothing left under the square root. And then b to the 3 divided by 2 is 1.5. So the 1 will come outside. The 0.5 means I have something left under the square root. Now when I write my answer, 16 is my number outside of the square root. A is completely outside of the square root. B is outside of the square root. And then under the square root, I have a 2 for my number and a B as a letter. There are no A's under the square root because my A's were even. So remember, the easiest thing to do with these is to break it up. Do your numbers, then your letters, all in different pieces. And then put it all back together. Whatever's outside goes outside. Whatever's inside stays inside. So problem 3 has been done for us. The square root of 81 is 9. The square root of a to the 6 is a cubed because 6 divided by 2 is 3. And the square root of b to the 8 is b to the 4 because 8 divided by 2 is 4. Now all of this, these pieces, they're all outside of the square root, so that's gone here. And then this AB that was out front has stayed out front. So remember, we simplify the square root first. Once we have that simplified, we bring this piece back in. So we have AB times my simplified square root. Now my simplified square root was 9a3b4, and I'm multiplying in an a and a b. We have a little note right here. Remember, when you are asked to multiply exponents, we really add them. So with our a's, we have 3 from the square root, 1 from the beginning, for a total of 4. With our b's, we have 4 from the simplified square root, 1 from the beginning, for a total of 5. And then 9 just stays out front because there's nothing to change the numbers. So when you complete these problems, you simplify the square root first, and then you multiply anything that was out front. So let's try it here. We're going to simplify the square root first. So we have the square root of 12, the square root of a to the 7, the square root of b, 11. So 12 can be broken up into 3 and 4. 3 cannot be broken up further. 4 can be broken up into 2 and 2. So we have 2, 2, and 3. I have a pair of 2's coming outside and a 3 staying inside. With my letters, both of these are odd, so both of these will have something left under the square root. 7 divided by 2 is 3.5. So the 3 goes outside. The 0.5 tells me to leave something under the square root. B's, I have 11. 11 divided by 2 is 5.5. So 5 will come outside. 0.5 tells me I have something left inside. So to simplify my square root, I have a 2 outside, a cubed and b fifth all outside. And then under the square root, I have a 3, an a, and a b. Now in front, now that I've simplified the square root, in front I had a 2. Remember, things that are outside can hang out with things outside, things inside can hang with things inside. So outside I have a 2 and a 2 for a total of 4, and everything else will stay the same because nothing else is changing. There's no a's and b's outside, there's no other square roots for the insides to change. Problem 5, we're going to do the same thing. We're going to simplify the square root first. So we have the square root of 72, x to the 5th, and y to the 4th. So 72, I put it in my calculator and it doesn't work nicely. 72 can be multiplied by 8 times 9. 8 can be broken up into 2 and 4. 4 cannot be broken up further. 2 cannot be broken up further. 4 can be broken up into 2 and 2. 9 could be broken up into 3 and 3. So I have 2, 2. I have 2, 2, 2, 3, and 3. So I have a pair of 2's and a pair of 3's coming outside. 2 times 3 is 6. And then I have a 2 staying inside. Now to deal with my letters, 5 divided by 2 is 2.5. So the 2 comes outside, the 0.5 means I have 1 that stays inside. For my y's, 4 divided by 2 is 2. Because I have y squared and no 0.5, there's nothing that stays inside the square root. So I have 6 outside, x squared, y squared. And then under the square root, I have a 2 and an x. And then out front, I had a negative 5xy that I'm now going to take part in. So all of the blue was me simplifying the square root. Remember, if you type a square root into your calculator and you don't get a nice number, then you should end up with one number, at least something left under the square root. So I simplify my number, simplify my x's, simplify my y's, and then put it all together. Whatever's out front goes out front, whatever's inside the square root is inside the square root. And now I'm bringing that piece from the beginning, the negative 5xy, back into my problem to simplify further. So out front can be multiplied with out front. Negative 5 times 6 is negative 30. X times x squared, we add. 1 plus 2 is 3. Y and y squared, we add. 1 plus 2 is 3. And there's nothing to change anything under the square root because nothing changes that because we didn't have anything out front. We have one more problem. So the square root of 121, m4, n5, and p7. So 121 is a perfect square, and we get 11, so we can stop at that one. And then m4, 4 divided by 2 is 2. So we stop there. 5 divided by 2 is 2.5, so 2 comes out. 0.5 means 1 stays in. 7 divided by 2 is 3.5. 3 comes out. 0.5 means 1 stays in. So I have 11 m squared n squared p cubed outside, and then n and p under the square root. And then out front, from the beginning, I had 3mn squared. So multiply 3 times 11 is 33. M and m squared, 2 plus 1 is 3. N to the 2 plus 2 is 4. And then this p has nothing to change it, so it stays p cubed. And then under the square root has nothing to change it as well. So again, your steps are to simplify the square root first, and then multiply by whatever's in front. Remember, number times number is normal. Little letters, so exponents, we add.